So equations in multiple angle. Most of the time, if you aren't given which wave function equation to use, you try and get alpha in the first quadrant. This will come with practice. A lot of the time it's easy. I'll explain how to do it and you'll find it relatively straightforward. So 6 sine x minus 8 cos x equals 5, and we've got to solve it. So we've got to solve using either k cos x plus alpha or k sine x minus alpha. So here, when we expand that, we're going to get cos x cos alpha minus sine x sine alpha. But the sine x is positive, so that one's not going to give us it in the first quadrant. Here, k sine x sine alpha minus k cos x cos x cos alpha. Cos x is negative, which means we'll get a positive. So it's going to be this one. So k sine x minus alpha, k sine x cos alpha minus k cos x sine alpha. Flip it round. K cos alpha sine x plus k sine alpha cos x. So with the cos x we had a negative 8, and with the sine x we had a 6. So k cos alpha is 6. K sine alpha, negative is positive 8. Both are positive, so it's the first quadrant. So k equals k squared, square root k squared sine squared alpha plus k squared cos squared alpha. So it's 8 squared plus 6 squared. So 64 add 36, which is the square root of 100, which is 10. So tan alpha is k sine alpha over k cos alpha, which is 8 over 6. Because it's the first quadrant, we don't need to bother doing the acute angle, because it's already going to be an acute angle. Inverse tan of 8 over 6 is 53 degrees. So 6 sine x minus 8 cos x equals 5 now becomes 10 sine x bracket x minus 53 degrees equals 5. Single trig ratio, we can solve these. We did these way back. So divide by 10. So we get sine x minus 53 is a half. Our acute angle is 30 degrees. Sine is positive in the first and second. So x equals minus 53 is 30 and 150, first and second quadrant. So x equals 83 and 203. Note, if you lose a value, so if we had to take 53 off and we got negative something, remember your other value is going to be, you add 360 to it. So if it's negative, you add 360 to it. If it goes past 360, you take 360 off it. So this one, solve root 3 sine 3 theta minus cos theta equals root 3. Oh no, it looks really complicated because there's a 3 theta. Not really. And we've got radians, oh joy, oh rapture. So we're using k sine 3 minus alpha. So k sine 3 theta minus alpha. So k sine 3 theta cos alpha minus k cos 3 theta sine alpha. Flip it round. K cos alpha sine 3 theta minus k sine alpha cos 3 theta. With the 3 theta, sine 3 theta, we've got root 3. With the cos 3 theta, we've got negative 1. A negative makes a positive. So k cos alpha is root 3. K sine alpha is 1. Both are positive, so it's first quadrant. So further down, k equals square root k squared sine squared alpha plus k squared cos squared alpha. So square root 1 squared plus root 3 squared. So 1 add 3, which is 4, which is 2. Square root of 4 is 2. So tan alpha is k sine alpha over k cos alpha, which is 1 over root 3. Because it's the first quadrant, we don't have to worry about getting the acute angle here. So alpha is 30 degrees, which is pi by 6. So root 3 sine 3 theta minus cos 3 theta equals root 3. We can replace the double trig here with 2 sine 3 theta minus pi by 6 equals root 3. Now remembering from before, 3 theta means we've got 6 solutions. So we're looking for 6 solutions here. So divide by 2, sine 3 theta minus pi by 6 equals root 3 over 2. So our acute angle, our AA, is sine A is root 3 over 2, so A is 60, or pi by 3. So changing it into degrees probably makes it easier for you. So 3 theta minus 30, because pi by 6 is 30, is 60, 120. That's our first two solutions. We then have to add 360 to both of these to get 420 and 480. We then add 360 to both of these again to get 780 and 840. So we've now got our 1, 2, 3, 4, 5, 6 solutions. So we add 30 to each side. So we get 90, 150, 450, 510, 810 and 870. We then divide by 3 to get theta. So we get 30, 50, 150, 170, 270 and 290. And then we convert them back into radians on that one.